Alright, we're gonna go over the quiz number 5, chapters 10, 11, and 14. Or 11, 12, and 14, whichever one it is. For video question number 1, the law of conservation of energy states that energy cannot be created or destroyed. An example of this would be fire. Fire gives off energy as a form of heat. That heat can be absorbed into many different substances and can increase their temperature and increase their energy levels as well. It also gives off radiant energy. For video question number 2, 6.75 gram sample of gold with a specific heat capacity of 0.13 joule per gram Celsius is heated using 55.8 joules of energy. The original temperature of gold would be 25.0 degrees Celsius. What I did to get 88.6 degrees Celsius was I took our energy, and then I divided it by the sample size times the specific heat capacity, and then added the original temperature. So I did 55.8 divided by 6.75 multiplied by 0.13, and then I added 25 and got 88.6. For question number 6, the following diagram, points where the addition of heat would cause some of the sample to evaporate would be F and G. At G, the substance still has somewhat of a liquid in it, so it would still have enough to, if it added more heat, there would still be enough to have some of the sample evaporate. At points where the specific heat of the liquid is used to calculate energy flow would be D to F. At F, the substance is still a liquid, and at D, it has just turned from a solid to a liquid. And so during the entire time that it would be considered a liquid, that's when you would actually use the specific heat of the liquid to calculate energy flow. Points where the temperature is equal to the melting point would be from B to D, so B, C, and D. The reason being, it's in the process of melting at that point, but still, even at D, it's still at the melting point. For question number 4, video question number 4, we have the emission line with the longest wavelength being B. E. The emission line with the longest wavelength would be E. Reason being that it'd be higher on the electromagnetic spectrum and have a longer wavelength. For B, we would also have B. Reason being, it would, just like E, it'd be higher up on the electromagnetic spectrum. Emission line with the highest energy would be D. Due to the fact that it is going through the largest transfer of energy and has more time to transfer all of the energy that it would need. The emission line with the highest frequency, though, would be D as well, due to the fact that it would be in the almost visible light spectrum, most likely. And it'd be way higher frequency than E or A. or E or B. The line corresponding to the ionization of energy of hydrogen would be A, due to the fact that it is consistently going all the way to infinity, which is what is one of the patterns of ionization of hydrogen. The absorption line with the lowest energy is would be would be B, due to the fact that it is the shortest line and would have the least amount of time to transfer or to have energy. I mean, it has the least opportunity, basically.